alpine glaciers form in mountain environments, and what they create are from valley glaciers, and we consider glaciers like rivers of ice. The same way a liquid river flows is how a glacial river flows. We've got the same zones where you've got fast moving material. In this case, it's faster moving ice where there's less friction. We've got slower moving water near the edges and the banks and the river bottom. Because of a higher friction coefficient, this is the same thing with this river of ice. The slower moving ice is along those margins that are in contact with the rock material. The thing about the different erosion characteristics in alpine environments, either whether they're created by water which is liquid or water which is frozen, is the shape of the landscape that's left behind. In environments that are classically eroded from liquid water, rivers the way you and I would normally call it, is they're V-shaped. Glacial valleys that have been created by ice have a flatter bottom and steeper sides, and so they're U-shaped. At the top of alpine environments where the material is first accumulated in places where the ice forms, where it does not melt over the course of summer months, that ice is stored, if you will, or does not melt in a little bowl that's sheltered from solar energy. So these end up creating bowls of ice as year after year more and more ice starts to accumulate. So think about this way. We know that snow is white, and white reflects because it's got high albedo. So the summertime, when we've got a big white patch, it doesn't melt. We get more snow produced in the winter. More snow means a bigger white patch. A bigger white patch means more reflection, means cooling in the summertime, which means we can retain more snow, which means we're going to make more ice available for the next year to accumulate on. So we've got a positive feedback mechanism functioning in these high alpine areas. These bowls of ice then sort of rotationally carve out material, and then we start to see them spill down the sides of the mountains to create this U-shaped valley or this river of ice. The stuff that gets left behind that's not eroded creates some classic shapes. We get horns at the top, so we would have had a U-shaped valley here and a cirque here, and then a cirque on the other side, leaving back behind these little points. So on these two photos here, I've got some horns that have been illustrated by previous authors. We can see where the cirques are currently located. These cirques would have occupied a higher elevation in the past to allow this feature to be formed. We've got saddles, which are the connection between two horns. So I've got a horn here and a horn here. This feature right here would be a saddle. And then coming down as this cirque is flowing down towards the valley, it leaves behind an arête, which are these linear features between cirques. So I have a cirque here and a cirque here, and then between those two cirques is an arête. In large landscapes like Yosemite National Park here, which is a glacier sculpted landscape, we can see two big U-shaped valleys. The primary valley, which is this one right here, and then we've got hanging valleys, and there are several hanging valleys in Yosemite National Park, and there are several hanging valleys in other locations as well, including places like Glacier National Park in Montana. So up at the top here, we would have had a cirque. That cirque would have flowed down in this direction, created a U-shaped valley, but then this valley, just like a tributary of a river, small tributary like the Mahoning River perhaps, would then flow into a larger river like the Ohio River. It's going to come and join the larger valley, and when this ice melts out and this ice melts out, it leaves a hanging valley behind. If we put some of these features together, we get a landscape that looks like this. So we've got our eroded features at the top, our horns, our arêtes. We've got a feature here called a tarn that I didn't speak of, but I really just want you to know arête, horn, and saddle. There's a saddle right here that was not labeled. Our cirque is up here. We bring this stuff down, create a U-shaped valley right here, which leaves us a hanging valley into this primary valley that's U-shaped here. So this is what we end up getting. Classic textbook image looks like this. We've got a pre-glacial landscape that has these V-shaped valleys. When we start to accumulate snow up in here, that snow and ice starts under its own gravitational weight and elevation, moves down the valley, starts to carve material out. That carved material then becomes agents to help erode the landscape. Over time, we occupy the landscape with a lot of ice, and once that ice is eroded out, we get these carved features left behind. So we've got cirques, and we've got a hanging valley here that's a U-shaped, and then we've got the valley that's a U-shaped valley here. A couple of additional features here, which are depositional forms that I haven't spoken of, are labeled as moraines. I've got a moraine right in here, and then I've got a moraine up here. And what moraines are is the debris that was carved out that gets left behind. It's just sort of like a dump truck of gravel, if you will. And the gravel is of a whole bunch of different shapes. The size of trucks all the way down to really fine grained material.